Hi everyone, this is Soumyadeep Paul, a mentor at CodeGardos and a software developer at Amazon. And today's video is not about our DSA and system design series, but it is about a very fun and interesting concept which I just now saw in a YouTube Shorts video. And I thought, why not? Let's share it with everyone. So, do you know why the usual MacBook laptops are much faster than your traditional Windows laptops? And I'm specifically talking about the M series of MacBook, M1, M2, M3, M4. They are much faster than Windows laptops, and also they have a lot of less heating than Windows laptop, and also their battery life is much longer than a traditional normal Windows laptop. This is because of a architectural brilliance that Apple has done in their MacBooks, which Windows is missing. Let us understand that. Now we all know that in a computer we have something called as a CPU, okay, central processing unit. Now CPU performs tasks in a sequential manner. CPU always performs tasks in a sequential manner. Sequential manner means one by one, okay, sequential manner, not parallelly. So the tasks are not performed parallelly. Okay, so the tasks are not performed parallelly. Okay. Now, whenever CPU is performing some operation, CPU needs to store its data somewhere. Now that data is stored in your RAM. Okay. Now, if you want to perform some huge operation, let's say multiplying 2000 cross 1000 matrices. Okay, multiplying 2000 cross 1000 matrices. Now, since CPU does operations in a sequential manner, doing this task of multiplying 2000 cross 1000 matrices will take a lot of time, because CPU will try to sequentially multiply every row with every column, and this will take a lot of time. So what CPU does is CPU knows that, okay, this is a very big task and I'm not good at it. So CPU delegates such tasks to GPU. Okay. Your computer will also have something called as GPU. CPU delegates these tasks to GPU because GPU can do parallel processing. Okay, can do parallel processing. So now GPU does the same task of multiplying 2000 cross 1000 matrices in a much lesser time, because it is able to do things in a parallel fashion. Now, for GPU to do some operations, GPU also needs to store the data somewhere, isn't it? But GPU doesn't use RAM. GPU has a specific separate store which is called as VRAM. Okay. So now, if CPU has those 2000 cross 1000 matrices in RAM and CPU wants to delegate that task to GPU, then CPU also has to transfer that data, that huge data of 2000 cross 1000 matrices from RAM to VRAM. So that data transfer, here it delegates tasks, it delegates the task. And here there is something called as a PCI express lane. Okay, PCI express lane. This PCI express lane helps in transferring data. Okay, transferring data from RAM to VRAM. It helps in transferring data from RAM to VRAM, so that now GPU can now perform those operations on that data. And once GPU has performed those operations, GPU has got some output. That output gets stored in VRAM, and then for CPU to access that output, GPU has to pass that output from VRAM, transfer that output from VRAM to RAM. So that transfer of data is a two-directional transfer. So it's a bidirectional transfer of data. It's a bidirectional transfer of data, not unidirectional. Okay. So your CPU can pass data from RAM to VRAM to delegate tasks to GPU. And the GPU can transfer data from VRAM to RAM after doing those tasks and generating some output. Okay. So that is why, and this transfer of data, this is a very heavy operation. This is a very heavy operation, and it requires a lot of electricity. Requires lots of electricity, lots of power. Okay. Since it requires lots of power, lots of electricity, this depletes the battery. This depletes the battery of Windows laptops very quickly. Okay. And also generates a lot of heat. It also generates a lot of heat. And obviously, if you have a lot of heat, unusual amount of heat, it can again cause thermal throttling, which will again slow down your laptop. Okay. So this is a problem. This is a bit problematic in your usual Windows architecture. This is a bit of a problem in your Windows architecture. So what Mac did with their M series in their M1, M2, M3, M4 laptops is that they changed the game completely. Now if you look at a Mac laptop, they don't have something called as RAM. No. This RAM has now changed, and Apple MacBooks, the M series, have something called as a unified memory. Now, what is this unified memory? This is a unified or fused RAM VRAM. A fused RAM and VRAM. Okay. So what Apple has been able to achieve architecturally from a hardware perspective is that now they have something like this. Not RAM, my bad. CPU and GPU. Okay. CPU and GPU, both together. So they are generating these M chips, the silicon chips, the Apple silicon chips. Okay. The Apple silicon chips, these are something unique. These are called as SoC, system on chip. These are called as system on chip. Okay. Now what does this system on chip means? It means that they have fused both CPU and GPU together. Now there isn't a separate CPU, separate GPU. And just like they have fused both the chips together, they have also fused the memory also together. Now they have a RAM and a VRAM, which together is called the unified memory. So they have been able to achieve this, that they are now having fused SoC chips, M chips, silicon chips that will have both the CPU and GPU together. And they have unified fused memory as well, which has both RAM and VRAM together. Now, if the CPU wants to delegate some task to GPU, there is no need for some data transfer. No need of data transfer now. Why? Because now the whole CPU and GPU can access the whole RAM and VRAM, the unified memory together. So if the CPU wants to delegate some task to GPU, all it needs to do is pass the pointer of that data to GPU. And just like CPU was able to access the data in that pointer, GPU will also be able to access the data in that same pointer. And then GPU does all the computations, GPU generates in some output, GPU stores that output in some memory location, and then GPU also doesn't need to transfer the data to some place. GPU can also just pass on the memory location, the pointer of the output to CPU, and that's it, done. Okay. So data transfer just got converted to pointer transfer. That's it. Pointer or reference transfer. That's it. This is what Apple is able to achieve. That has changed the game for their M1 series laptops. That is why their laptops have a huge battery life right now, and they're also much faster than the traditional or present generation Windows laptops. Okay, so I hope this was an interesting fun fact for all of you, and I'll see you all in the next video, where again we will continue with our DSA series and our system design series. And if you want to prepare for really good top-notch product-based companies with 20, 30, 40, 50 LP packages, and if you want to get yourself trained in DSA system design or generative AI or DevOps, straight from developers who themselves are working in Mang companies just like me, then do join CodeGardos.